right? 4 problems, you need Slater, come on. Just, you guys know how to factor. What factors a negative 24 add to negative 5? Right, negative 8, positive 3. This is easy stuff. Quit being so lazy. Where's my pens? There they are. So x minus 8 and x plus 3. Remember, it's got to be 0 on the right. So a couple of them on your homework wasn't like that, so you had to move it over first. Okay? So x is 8. You guys know you're supposed to set it equal to 0. So it's basically the opposite of what's up there, right? So those are my critical values. So I'm graphing it. 8 is up here. Negative 3 is down here. Okay? Will I have circles or dots at those points? Dots. I'm going to dot you upside the head.
Oh, I think the dotted line.
Oh, you mean this kind of stuff? Right. These are the critical values. But since it's no equal to, these are circles, right? If they had the equal to, we make it solid dots. Okay? Now, how did I figure out which way to draw my arrows?
Plug it back in.
Plug numbers in, right? So what number do we want to plug in left of negative 3? Negative 4 is the easiest, right? But anything left of negative 3, right? What's the easiest one in between these two? 0, right? But any of those numbers in between there is fine. And then what should we use over here? 9. We okay with that? Doesn't take that much work for you to do it this way. Okay? So I substitute in negative 4 into the original problem. So I get positive 16 and a positive 20 because it's negative times a negative, minus 24. So that's 36 minus 24, that's 12. Is 12 greater than 0?
Yeah.
Yeah, so I'm going to go that way. Because it works. When I put 0 in there, I get 0 squared minus 5 times 0 minus 24. So 0 minus 0 minus 24 is a negative 24. Does that work? Is that greater than 0? No. So I wouldn't draw an arrow between those two, or a line. And then I go 9 squared minus 5 times 9 minus 24, which is 81 minus 45 minus 24. What's that? 69? 81 minus 69 is 12. Is that greater than 0? Yeah. So that's one. Yesterday all of them went in between, but that one went outside. With 2 ends. Is that difficult? Well, that's pretty easy, isn't it? You guys are good at factoring. Should be. Okay? So just factor it and then graph. Everything's graph. No intervals. Okay? That's what I'm going to do on the quiz for you. All right, so number 30 was a dotted 0 and a dotted 5, and you connect them in between them. 32, circle at negative 7 going to the left, and a circle at 7 going to the right. So it looks like that one. 34, circle at negative 3, a circle at negative 2, and connect them. So since they were right next to each other, for that middle part, to see what worked, I would use negative 2.5. And then for 36, you had to add the x and subtract the 30. So it would be, 6 times negative 5. That makes your two numbers, -6 and +5, right, Jacob? So then you have a circle at -6, a circle at +5, and you would connect those. Okay? Any of those you'd like me to go over? Eaton, I would appreciate if you listened to me today instead of do something else, okay? So you have a clue of what's going on. Because your homework was all wrong. Okay? Today, we're doing rational inequalities. So again, just like last week, we did quadratic stuff or polynomial stuff, and we did fraction stuff, we did radical stuff, we did exponents that were fractions, okay? On our last quiz, where we got some fractions again on the inequalities. On these, just like yesterday, it has to have a 0 on the right. So I have to move that 3 over. How do I move it over? Subtract it. All right, so I've got 5x minus 9 over 5 over x minus 5. Minus 3 is less than or equal to 0. All right, so we want 0 on the right. Now, how do I subtract 3 from a fraction? If I have a subtraction problem, what must be true so I can subtract the common denominator? Okay? So there's only one denominator, so what's the common denominator going to be? X minus 5. So since I had to put an x minus 5 in the bottom, what do I got to do in the top? An x minus 5 in the top, right? You guys with me on that? Okay, now I can subtract them. But before I subtract them, this means to do what? This -3 and this x minus 5. Means to multiply. Got to do multiplication always before subtraction or addition, right? So I have to distribute this. So -3x and -3 times 5 is a +15. All right, so what I want to do here is make it one fraction. So I've got my denominator. Now I just have to simplify my numerator. So I got a 5x minus 3x, which is 2x. And then -9 plus 15 is a 6. Okay? So that's what I want. I want to make it a problem that has a single fraction, less than or equal to, greater than or equal, that doesn't matter, 0 on this side. Okay? So any questions on how I got that new fraction, the green one? Okay, so I distribute that -3, then I combine my terms. Now, I figure out what makes the top 0. And I figure out what makes the bottom 0. To get my values, my critical values, like we did yesterday. Okay? Now we're going to do the same thing we did yesterday. So this critical value is 5. And this critical value is -3. Okay? So you want to figure out what makes the numerator 0 and the denominator 0. Those are our two values. Okay? And then we're going to graph. Now, here's where we got to think. Are we allowed to have the denominator equal to 0? Ever? No. Okay? So, even though this has less than or equal to, at the 5, whatever the number is, it gives you this bottom 0, the denominator 0. Always has to be an open circle. Okay? Even though we have the equal to here. All right? It can never be 5 because that makes that bottom 0. We can't do that. So that whatever makes the denominator 0 is always an open circle, whatever number you get. Okay? Now, it's okay to have 0 in the top. So since it does have the equal to, the 3 would have a solid dot. And then we do what we did yesterday. We just pick numbers in each section in the original problem to see what works. So again, I'm just going to check -4 on this end. I'm going to check 0 on this end. And I'm going to check 6 on this end. So it's the same thing as yesterday. But you do the original problem. Don't do the one you change it to. Do the original. Okay, so we're going to put -4. What was it? -4, 0, and 6. And see if it's less than or equal to 3. So -5, or I'm sorry, 5 times -4 is -20, minus 9 is -29, over -4 minus 5, which is -9, right? What's two negatives? A positive, right? Okay. So 29 divided by 9 is 3 2/9. 2 left over, right? 9 goes into 27 3 times. Is 3 2/9 less than or equal to 3? Bigger, right? So we would not go towards this side. Okay? Let's plug 0 in. 5 times 0 is 0, minus 9 is -9 for the top. 0 minus 5 is -5. Okay, so that's a positive 1 4/5. Is 1 4/5 less than or equal to 3? Yeah. So we're going to connect the dot and the circle. Okay? And then we're going to put 6 in. 5 times 6 is 30, minus 9 is 21. And 6 minus 5 is 1. 21 divided by 1 is 21. Is that less than or equal to 3? No. So it's just in between. And usually, if it's in between, it's not either end. But every now and then, we'll get one that'll have in between and then one of the ends, but not very often. Questions on what I did?
What happens with the bigger 3x and 15?
Here?
Yeah.
Okay. Once I distributed, then I combine the like terms. I can, put these together now because they have a common denominator. So I went.
You combine with the denominator.
Well, the denominator just stays whatever it is. So that stayed x minus 5. Then I went 5 minus 3x for the 2x, and -9 plus 15 for the 6. Okay? Any other questions? So again, first thing, look what it was to start with. We had a 3 over here, so we had to subtract the 3 over. We wanted 0 on the right. And then in order to subtract 3 from this fraction, I got to get that common denominator. So this, the bottom becomes x minus 5, so you got to multiply that -3 by the x minus 5. Combine like terms to make it a single fraction, and then figure out what makes the numerator and the denominator 0. And that becomes your two numbers that you're going to graph. And then check your numbers. So why don't you guys try this one for me, please? And then I'll give you homework. When you get it, I'll check it. Right, you guys are doing a pretty good job.
What makes that zero though? Yeah, the top. Right, so that's your other number. Right?
Okay, see how you did? Good job, thanks for working on it. All right, so we're gonna subtract the 2, right? So we got 3x plus 4 over x plus 1 minus 2, and then we're gonna make it x plus 1, right? So that's a 0 there. You guys okay with this fraction over here now? Whatever that is, you're just gonna multiply that 1 you brought over by that and put it over x plus 1 so that you'll have this one fraction over x plus 1. If I could turn this on for you. Okay. So if you want to distribute the negative 2, you can, or if you just distribute the 2 and then subtract, either way works. You got 3x minus 2x and 4 minus 2. So that's a fraction you should get after you put them together. Okay? Got any questions up to there? Does that make sense? Okay. So then what are my 2 values, Matt?
-2 and 1, and -1.
Yeah, -2 and -1. Okay. Which one's got the circle? The -1. Remember, the denominator always is the circle, even though we had equal to that. If the equal to is not there, they're both circles, right? But for the top, it's okay to be 0, equal to 0, so that's the solid dot. So my numbers I'm going to pick are -3, -1.5, or -1.5. And then over here is 0, so I'm going to use 0 on that end. Again, just any number that's in those areas. And you can pick a different, but if it's 2 numbers like right next to each other, like, I always just go halfway between when I do. So again, we go back to the original problem to plug those in. All right, can I see them? Yeah. So 3 times -3 would be -9 plus 4, which is -5. And then -3 plus 1 is -2. That's a positive 2.5 because there are 2 negatives. Is 2.5 less than or equal to 2? No, so I wouldn't go in that direction. Okay, let's do the 0 real quick. 3 times 0 is 0 plus 4 would be 4, right? And then 0 plus 1 is 1. Is 4 less or equal to 2? No. So what's that mean? Neither end works? It must be here, right? Well, let's just check to make sure. So I'd go -1.5 times 3 plus 4 over -1.5 plus 1. All right, so that's -4.5 when I multiply that, plus 4 is -1/2. Then -1/2 plus 1 is a -1/2. What's a -1/2 divided by -1/2? Positive 1, right? Is 1 less than or equal to 2? Yeah. So that was correct, what we thought would happen, because the two ends didn't work. Questions?
If none of the numbers work, is it a solution?
Right, if nothing works, there will be no solution. There should be something that works. All right? So, fraction ones, move that number over, set it equal to 0, get it to a single fraction, and then find your critical values and do what we did last night for the graph. Remember, solve and graph, no intervals. There are 5 problems. And they all pretty much, I believe, look like that. 38's already got the 0 for you. And 44.
No, I couldn't hold it.